Hello, in today's video we're going to be learning how to simplify rational expressions. Essentially what that means is we're going to reduce fractions with polynomials. Before we start that, I'm going to do a little old school fraction reduction problem. Most of you, when you look at 15 over 30, automatically, you've been doing these so long, your brain tells you it's 1/2, which is true. What you're really doing, without you really knowing it, is first you need to factor these top and bottom numbers. So what's really happening is 15 is 3 times 5, and 30 is 2 times 3 times 5. And what's happening is these 3's and these 5's cancel out, leaving a bunch of 1's, right? And then when you multiply back together, you get 1 times 1 over 1 times 1 times 2, which is 1/2. So what you really have to do when you're reducing a fraction is factor it and then reduce common factors. So that leads us to something Mackenzie Lynch made up here, FRED, which stands for factor, reduce. Okay, so that's going to come in big through this whole chapter, factor, reduce. Always remember that we're going to factor and then reduce. So let's go to a new problem here. It looks very similar. It's kind of the same thing, except there's an x there. So we have 3 times 5 times x over 2 times 3 times 5 times x. And again, we want to get rid of these 3's and get rid of these 5's and get rid of these x's. So we have 1 times 1 times 1 over 2 times 1 times 1 times 1. And we know that that is 1/2. Pretty much the same as the last problem. However, what do we do if we get a fraction that looks like this? 5 divided by 0. Or 0 divided by 0. Are we allowed to do that? A lot of you guys will remember that we're not allowed to divide by 0. So we have to come up with a new rule. So the rule is, if you have something, could be anything, we'll call it x, divided by anything, we'll call it ABC. If this is true, then A is not allowed to be 0, B is not allowed to be 0, and C is not allowed to be 0. So, in my own words, what that means is the bottom of a fraction is not allowed to be 0. Therefore, any factors that make up the bottom of a fraction are not allowed to be 0. So the fact that there's 3 letters down here doesn't really mean anything. That could be 10 letters or 2 letters or 1 letter. But the basic thing that you need to remember is you cannot divide by 0, so any factors on the bottom cannot be 0. So Mackenzie Lynch changed her thing to FRED, and so now we have 3 things, and that's all we're going to have. So factor, restrict, reduce. It's important that restrictions come second, because once you reduce, sometimes you lose some things that you want to restrict. So in this case, the answer is 1/2 as long as x is not equal to 0. So you have to put that. So what you do is you factor 3, 5x, 2, 3, 5x, restrict, so this is part 2 here, x cannot be 0 because it's one of the factors on the bottom. You don't have to say that about 2, 3, and 5 because obviously those aren't zeros, but x could be. So we have to say x can't be 0, and then we put our answer, 1/2. Okay, so we'll practice that. FRED, remember that, FRED, factor, restrict, reduce. Okay, so we have this problem here. Let's see, no, I wanted to switch that. So let's do this problem first. So, FRED, remember, write that down, make a flashcard, factor, restrict, reduce. So the first thing I'm going to do is factor. I want to find on top, since this is a binomial, I'm looking for the greatest monomial factor. 2m and 5 have nothing in common, so that is done. 6m and 15 do have something in common. It is a 3. So when I factor out a 3, I'm left with 2m minus 5. So now I have factored. Now I will restrict. 3 obviously is not 0, but this 2m minus 5 is not allowed to be 0. So I'm going to say, how do I do that? So we'll do 2m minus 5 is not equal to 0. That's not enough. We're going to solve for m in this case. So if I add 5 to both sides, I get 2m is not equal to 5. And if I divide by 2, I say m is not equal to 5 over 2. That's my restriction. Okay. Now to get my answer, I can back up here and actually do my reduction. 2m minus 5's cancel out, leaving me with 1 over 3 is my answer. So 1 over 3, comma, m cannot be 5 over 2. Let's keep going. Now I have two trinomials in a fraction. So I need to red, factor, restrict, reduce first. So I'm going to factor the top. Factors of 8 that add to negative 6 would be negative 2 and negative 4. So c minus 4 times c minus 2. You can see again the factoring's coming back, so we're going to get more practice. If you've already mastered it, then you'll be doing these problems much faster, which is great. Okay, and factors of negative 6 that add to 1 would be 3 and negative 2. So c plus 3, c minus 2. Great. Okay, now I have to make my restrictions. Now since there's two factors that involve a variable, I'm going to have to make two restrictions. So c plus 3 cannot be 0. So I'll solve that one. So c cannot be negative 3. And then c minus 2 cannot be 0. So c cannot be 2. Now I've got my two restrictions here and here. Now I can do my reduction, because that's the last part, reduction. C minus 2 and C minus 2 are factors. So my final answer is C minus 4 over C minus 3, comma, C cannot equal negative 3, and C cannot equal 2. So here's my final answer. Alright, let's go for another. We're going to have a new rule here. Let's see why. So first of all, red. Factor, restrict, reduce every single time without fail. I can really tell the people who have no idea what's going on when I ask a question and they start reducing first and trying to do like negative 4 over negative 2 is negative 2 or 2. I can tell that they haven't practiced at all because they're not factoring first. So I'm going to factor out a 4 here, leaving me with 3 minus t. And then on the bottom, factors of negative 3 that add to negative 2 would be negative 3 and 1. That works. Okay. So here, first we have to do our restrictions. Not a problem. So I know that t minus 3 cannot be 0 and t plus 1 cannot be 0. So t cannot be 3 and t cannot be negative 1. Okay, now I'm going to go to my restrictions. I just did this, so now I'm going to do reduction. So 3 minus t and, well, these look really similar, but they're not. They're not the same. So what does that mean? Well, let's figure out what this new rule is going to be. And I'm going to go old school. Let's figure out the new rule with some simple examples. 10 minus 8 equals 2. 8 minus 10 equals negative 2. Let me write down another one. 7 minus 4 equals 3. 4 minus 7 equals negative 3. Alright, some of you may have it by now, but if we're doing subtraction, if you flip the things that are being subtracted, so the 10 and the 8, if you put the 8 first and the 10 second, you get the opposite answer, 2 and negative 2, 3 and negative 3. So you get the opposite of what the other one would be. That doesn't happen for addition, by the way. You get the same answer. So this is only true for subtraction. So the rule is, if you have x minus y, that is the same as the opposite of y minus x. Alright, let's show you that with numbers so you're not like, what the heck's going on? We'll use the 10 minus 8 one. Or I'll make up a whole new one. 11 minus 4 is equal to negative 4 minus 11. Okay, simplified, that means 7 equals the opposite of negative 7, which is 7. Right? So you can see that these are the same. So whenever you need x minus y to look like y minus x, you just put a minus in front. So how does this apply to this current problem? Let's slide that up a little more and move down Fresred here. Well, I want this to look like that, or this to look like that. So what I can do is say 4 times 3 minus t over, I'm going to switch that, so I'm going to make it look like 3 minus t, just like this top one. But in order to do that, I have to put a negative in front, right? So to flip the y and the x, I have to put a negative out there. And then the t plus 1 stays the same. Okay, so now I do have this 3 minus t that I can cross out. But don't make a mistake. Don't cross out that negative there, because that has to be there. So we end up with our answer of 4 over negative t plus 1. Now if we were to distribute that negative, if we were to fully simplify, which really means take out parentheses, that would be 4 over negative t minus 1, right? And with our restrictions, which we found out up top, which were t equals, is not equal to 3, and t is not equal to negative 1. Okay, so this is a really, it's not really a challenging section, as long as you remember Fresred and this rule here. If you remember Fresred and this rule here, you're going to be super set to go. If you don't remember those, then you're in big trouble. Alright, thanks for watching.